So now let's take a look at question 1 here. Use the definition of definite integral and approximate the summation formulas to evaluate this expression. Okay, so we're gonna start with the definition. We have the interval from -1 to 3, right? So I'm gonna set a equal to 1 or -1, and b is gonna equal to 3, right? And so I have this delta of x is gonna be equal to b minus a divided by n, because we want to have n subintervals. So that's gonna be 3 minus -1 over n, right? That is 4 over n. And now xi, what is my xi? Si is gonna be a plus I times delta of x. That is equal to -1 plus I times this 4 over n, that is 4i over n. So that is the setup of this question. We collect these informations first before we write out the summation and the limit. That is the definition of this definite integral. So now, after having this, I can now write this from -1 to 3, this definite integral. By definition, that is going to be limit n goes to infinity of this summation starting from 1 ending at n of this it's gonna be f of xi times delta x, where f of x should be this guy here. This is f of x. And now I plug in this. So I'm gonna plugging in this xi in here, xi which is -1 plus 4i over n into f, right? So I'm gonna replace the x in that in the expression by this guy here. So replaced. Now I have 2x, right? 2x, and that x is replaced by the green stuff, which is this -1 plus 4i over n, right? 2x minus 1, so minus 1. That is my f of xi. And I also need to write out the delta x. Delta x, I have that here. That is this one, right? So 4 over n. So that now my expression is complete. Now the rest of the work is just to simplify this. So simplify this, I have that this is -2, right? -2 minus 1, that's gonna be -3, right? So -3 here, plus this 8i divided by n. If we open the bracket and multiply that out together, multiply with 4 over n. Okay, so that is the expression. And now we're gonna work on the summation. Okay, the summation is about I, so we're only interested about the I. So we're gonna separate those terms that has the I and those terms that does not. So that is obviously the first term and the second term. So continue, I have this negative 12 n here, right, plus this 32i divided by n squared. Okay, and I can factor out the n because the summation has nothing to do with the n here, so factor them out. So I have right now this negative 12 divided by n, right? I from 1 to n, this is 1. And the other summation, so I factor out this 32 divided by n squared. Summation is I from 1 to n, I. So basically these two summations. We know the formula for these two summations. The first summation is just simply 1 plus 1 plus 1 all the way to the nth one. So it's going to be n for the first summation. So I have here negative 12 over n times n. That's the first summation. This is n. And for the second summation, that is going to be n times n plus 1 divided by 2. Right? It is a formula in a textbook which you can look up. And I also remind you about the other formula here you will encounter very soon. That is the summation of the square. That is going to be n times n plus 1, 2n plus 1 divided by 6. So we all need to keep this kind of formula, basic formula in mind in order to work on the summation stuff. And we can always factor out the things that does not have anything to do with I. But for I, we cannot factor it out because that is what we are summing for. Okay, so knowing what is allowed to be factored out, what is not allowed is very important. Now we have successfully get rid of the summation, and all we have left here is the just the expression, some kind of expression about n. So clean them up, starting with this, cancel this out, and also this n is gonna cancel with this square. Okay. Now 32 cancel with this 2. I am left with 16. Okay, so continue. I have this negative 12 plus 16 n plus 1 divided by n. Okay, and continue. I can open the bracket, or I don't actually need to. I can just split the limit into this, or maybe one more step to be clear. So that's gonna be negative 12 plus this 16 times 1 plus 1 over n. Okay, and split the limit, and then let n go to infinity. So this guy is gonna be 0, right? Goes to 0. So the answer is negative 12 plus 16, which is positive 4. Okay, so that is a very tedious, right? And it has lots of computation in between of these things. And the most difficult stuff is to, I think, working with the summation and how we can manipulate so many terms here. Of course, setting this up, we need to understand how do we write out the the summation first by setting a equal to what, b equal to what, and then the delta of x equal to what. That is all about the definition we should be familiar with. If you're not comfortable with this, then check out the textbook for the definition, and also review some kind of a formula about the summation. Okay, so that is question 1, which is a long shot, definitely. Now we want to move on to question 2. Hopefully that will be easier than the question 1. So express the following limit as a definite integral. So that is completely the other way around. The previous question asked us to express a definite integral by using the summation, the limit, right? And now it asks us to do the other way around, to go back to the definite integral by using the summation. So firstly, I want to emphasize that the way we write it as a definite integral, it's not unique. So there are many different ways of writing this as an integral, definite integral of some kind of function, depending on what kind of integral you're going to choose, what kind of function you're going to choose, the answer is going to be different. So I will start with the standard method, and then you can go from there to find out which way you actually prefer. So now I will, so we need the integral, right? So we need the integral. What is the easiest integral that we can think of? That is this interval, 0, 1. So I will let a equal to 0. So firstly, let a equal to 0 and b equal to 1. All right? And we also need to divide this interval into n pieces to create those rectangles. So delta of x is going to be b minus a divided by n. So that is 1 minus 0 divided by n. That is 1 over n. And I also need to find my delta of x, the xi, not delta of x, by using this a plus I times delta of x. So that's going to be 0 plus this I times the 1 over n, which is I over n. How can I think of all this stuff? No, I don't know. I'm just guessing, because as I said, the way of writing it as a definite integral is not unique. So this is the first way that you can follow and see what you can get from there. So after writing this out, I'm gonna imagine that my expression here, this expression, is gonna be written as limit n goes to infinity, summation I from 1 to n, and I will have f of xi times delta x, right? So I will need to make up my delta x and the f of x here. Since we have chosen the delta x to be n minus 1 divided by n, so what is our f of xi if we choose delta x to be 1 over n? So the expression can be written as, the expression here, 2 divided by n, 3i over n plus e, can be written as 2 times this plus e times 1 over n. As I said, we have chosen delta x to be our 1 over n, right? So this is the delta x. And if we compare this expression to the desired expression, then we see that our f of xi has to be the remaining factor here. So we're gonna think of this as our f of xi, right? And we also know what xi is. Xi is this guy here. Is this guy here. Now after comparing these things, we can figure out what the function f of x has to be. This thing is going to be our f of xi, right? Now what is the function? The function is obviously has to be 2 times 3x plus e, right? If we replace the x with I divided by n, we're going to get the exact same expression as above. And that is how we, find out what the f of x has to be by assuming at first the interval and the xi and the delta of x and all sort of those things. Now we've known everything. So I'm able to now write this expression as the definite integral. So that is going to be summation from 0 to 1, from a to b, right, as above. And then my function f of x, that is here, which is found just now, 3x plus e dx. Okay, so that is how we figure this out. A little summary about this, that is, we need to know what the interval is. We also need to know the function. Okay? And if you change the interval, if you choose another interval, the function has to be different in order to fit this expression. So the answer is not unique. Okay. So after this, I'm going to show you a alternative way of writing this. So alternatively, I'm going to write second, what if we don't let a equal to 0 and b equal to 1? What if I choose the other interval? So let's suppose that I have a equal to 0 and b equal to 2. Let's see what happens here. If we go this way, then we're going to create delta x equal to b minus a divided by n, which is 2 minus 0 divided by n, and that's going to be 2 over n. And continue, we create this xi, that is a plus I times delta of x. That's going to be 0 plus I times 2 divided by n, excuse me, as 2i divided by n. So now we see that the delta x and the b and the xi, they have become different. Okay, so as above, we're going to think of that expression here as f of xi times delta of x. Okay, so this expression here, imagine that this expression 2 divided by n times 3i divided by n plus e is going to be f of xi times delta of x. Now what is my delta of x? My delta of x is this guy here, right? And that guy is already here. So if this 2 divided by n has taken up the space for delta of x, then the remaining, for the remaining factor here, the f of xi has to be this guy, right? And now I also know what my xi is. My xi is 2i divided by n. So it's this one here. So I'm going to express this expression in terms of xi. So this expression is going to be this one, and it's going to be 3/2 times 2i divided by n plus e. Okay? Now we have had this xi here, and we know that this expression has to be f of xi. So this way we know what the f of x has to be by thinking reversely. So f of x has to be 3 divided by 2x plus e. So we also can check whether this f of x is correct by plugging in xi into this expression and see if you get exactly the expression above. So that is how we obtain this f of x, by comparing the things here. Now after having all these intervals and the f of x, we write the expression out. So the expression here can now be written as a definite integral that is from a to b, 0 to 2, and f of x, that is 3 divided by 2x plus e, right, bracket 2x. Now we want to compare this with our previous expression. So our previous expression is here. And this is the new expression. They're both valid. They're both definite integrals expressing the limit of the summation. But they are different as we chose different integral, and the function is also different, right? So as the integral changes, the function will change accordingly. That's why the answer is not unique. So you can now figure out what is your preferred way of doing that. Personally speaking, I would like to let the interval to be 0, 1, because that is easy to work with. But you may want to let it to be something else depending on your preference. As long as the function you ended up does not seem very strange, then that is completely fine. You don't want some complicated expression to get in your way to screw your answer here. So that is how tricky this kind of question can be, and that is question 2. So now let's take a look at the rest of the questions here. Since we don't have enough time, so I will skip some questions. We will basically focus on the difficult questions here. So now let's take a look at question 3. Use the comparison property for definite integrals to prove that this is less than 4. So what does that mean? So the idea here is to prove that this value of this definite integral is less than this given value. We know that definite integral, it's a summation of some kind of rectangles. So if we can approximate, find a upper bound for the entire function, then we can kind of bound all of those rectangles so that the sum of those rectangles will be smaller than this value. So the first thing is to find a upper bound for this guy. Okay. How can we find upper bound for this guy on this interval, -1, 1? Well, we know that this 2x, it's a increasing function. So the larger the x is, the larger this value is. So we can kind of plug in the maximum value in this interval to obtain the maximum value of this exponential function. So this is less than 2 to the 1, which is equal to 2, right? And for the other factor, this division can be viewed as multiplication. So we can view this thing as 1 over this, right? This is kind of a reciprocal function. So the less the x is, the greater the output is. So we can now input the smallest value into this fraction to get the smallest denominator. So the fraction will become the largest at that situation. So we plug in -1, so this is less than 1 over -1 plus 2, which is 1, right? And this thing, this expression here is actually the product of these two things. So it's equal to 2x multiplied with 1 over, right? And we can follow the direction of this inequality, which is less than, for the first factor here, this factor is less than 2, right? And for the other factor, this guy here, is less than 1. So overall, the product is going to be less than or equal to 2. That is a upper bound of this function. So it means that all the rectangles inside this interval is going to have the height less than or equal to 2. Okay, so that is the upper bound. It's easy to see that the rectangles are all positive because this is a positive function on this interval. Right? You will not get negative value by plugging in any number in this interval. So now I can find an upper bound for this definite integral by replacing the function with the maximum value, not actually maximum, but a upper bound, right? And then this is gonna be from 1 to -1 to 1, 2 dx less than, and this is gonna be 2 multiplied with the length of this interval, that is 1 minus -1. That is the length of this interval. So 2 times 2, that is equal to 4. Okay, so now we see that this one is less than or equal to 4. It's a proof type question. We can actually get a better bound if we use the the first derivative method to find out a better upper bound, but we're not doing that here. Just get a taste of this question. We will do better in the following exercises. So that is our question 3. Now let's move on to question 4. Okay, so this question 4, I may just go over the first one, since the second one is similar. You can actually find this from the 1500 is a old exercise. We have done this in 1500. So so we find the derivative of this one. Obviously, the idea is to use the fundamental theorem of calculus, right? So this is equal to f of x, right? And now d f dx, it's equal to, by the fundamental theorem of calculus, that is equal to, firstly we rewrite this by switching the upper bound and lower bound. That is 5 here, 1 minus x here, by placing a negative sign here, 3t, t squared plus 2 dt. The fundamental theorem of calculus says that the derivative of this kind of function relative to x is just gonna be the inside expression with the variable t replaced by the upper bound, and that times the derivative of the upper bound function. Okay, so we're gonna write out this thing here. That is 3t divided by t squared plus 2, with t replaced by 1 minus x. And this thing is gonna multiply with the derivative of 1 minus x. Of course, so we have a negative sign here. Okay, so now I have 3 1 minus x divided by t squared, that's 1 minus x, bracket square, plus 2, right, the negative sign, multiply with this derivative of 1 minus x, that is just negative 1. And these two negative cancel, so I am left with 3 1 minus x divided by 1 minus x squared plus 2. Should not be a very too difficult question. You can look it up from the Math 1500. Okay, so that is our question 4, the first one. For a second one, I maybe briefly mention the idea. So we have not only the upper bound but also the lower bound here. So what we need to do is to split this into two intervals. So two integrals from this to insert a value to 0, tangent t3 dt, plus from 0 to 2x, tangent t3 dt. Now after that, we're going to treat this the same way we did for the previous question. Just follow the formula. Okay, so that is our question 4. Now let's move on to question 5 and question 6. I don't think I have enough time, but let me choose a question here to work on. I think maybe D and F, that is difficult. Okay, so D here. The trick is to rewrite this function so that we are able to use the formula from our formula sheet. You don't want to have a product of two different functions. How do we do that? So we're gonna rewrite this 3 to the 2x into 3 to the 2 and again to the x. So that's gonna become 9 to the x, right? So this one is 9 to the x times e to the x dx. And now since they have the same exponent, I can combine the multiply the base here, so it becomes 9e bracket x dx. Okay, so that is the exponential function, and we know what the formula is for the antiderivative of the exponential function. It goes like this. 1 over ln a times e to the x plus c, right? We can always take the derivative to verify this answer. So this is gonna be ln times 9e, 1 over which times the 9e to the x plus c at the very end. And after we finish this, we can take the derivative of this answer to see that if it goes back to the original answer, the original expression. That is a way to verify this. Okay, so that is question D here. It can be actually simplified further. This ln 9e can be written as ln 9 plus ln e, right? And ln, ln 9 is ln 3 to the 2, ln e is just 1. So it becomes 2 ln 3 plus 1 if you want to simplify it that way. But you don't have to, I think. Now take a look at this question F. That looks very complicated. So for this question, we're gonna simplify the inside expression here. This expression. So we multiply through the brackets first, sec square x plus sec square x times sine of x. This dx, right? And that is equal to sec square of x. And we're gonna change the sec in the second factor here to be 1 over cos square x sine x here, right? And now what I can do is I can write this as sine of x over cos of x times 1 over cos of x. And I continue to change this sine divided by cos into tangent of x, right? And the this 1 over cos x, I write it as sec x. Okay, so just play with this kind of formula. So now this becomes tangent of x times sec x dx, right? And that is, exactly tangent of x for the first interval for the first integral here. And for the second integral, that is going to be SEC x with plus c at the very end. You know, both these expressions can be found in the formula sheet. We have the antiderivative for both these expressions. So if you're not familiar with it, just look it up. Right. So that is question F, probably tricky here. But as we practice more, we will get more comfortable with these questions. Okay, so maybe let's do one of this question in question 6. Which one is more difficult? Maybe the last one. I don't think the last one is difficult. Maybe just do it. We actually have encountered this kind of question in 1500, so it should not be a new stuff. For this definite integral, our weapon is the fundamental theorem of calculus, right? So we basically find the indefinite integral first, and then we plug in the value, the upper bound and the lower bound, and we do the subtraction, right? So this is gonna be, firstly, simplify the expression, 1, 2. That becomes 3x to the 2, right? Minus 2x, this is minus 1, plus x to the minus 2, right? Dx. And now it becomes, from the formula, the first term is gonna be x3. The second term is gonna be 2 ln of absolute value of x, straight from the formula. And the second term, the third term here is gonna be 1 over x. And notice that this sign is negative, right? If you're not comfortable with seeing this, I remind you of this thing. This x to the n dx is gonna be n plus 1, x to the n plus 1 plus c, right? And n here is not equal to negative 1. So we are basically using this formula. Right? The 2 here, right? This is the n, right? N plus 1 becomes negative 1, and that's where the negative sign comes from. And so this becomes, write that in more details. X to negative 2 dx. That is negative 2 plus 1 over this, times x to the negative 2 plus 1, right? Plus c. And that is going to be negative 1 times x to the negative 1 plus c. Is exactly this thing. Okay. Hope that clarifies. And we also need this c here, right? But now we're not looking for the definite integral. We're not looking for the indefinite integral. We're looking for the definite integral. So we're gonna, just put the upper bound and lower bound here. Okay, instead of putting c. And now we're gonna substitute 2 and 1 into the first expression. So it's gonna be 2 to the 3 minus 1 to the 3. That is the first term. And for second term, it's gonna be 2 times this ln, absolute value of 2 minus absolute value of 1 here. Okay, minus, this is going to be 1 over 2 minus 1. Okay, so that is going to be 8 minus 1, that is 7. Okay, and the second term, that is ln1 is 0, so we just minus 2 ln2. And for the last term, that is just plus 1 over 2. So the final answer is negative 2 ln2 plus 7 1 over 2, that is 15 over 2. Okay. If you're not comfortable seeing this subtraction, you can do the other way. You can do this. So plug in 2 first. 2 to the 3 minus 2 to the ln 2 minus 1 over 2, right? That is the expression obtained by plugging in 2 minus the expression obtained by plugging in 1. So 1 to the 3 minus 2 ln 1 here minus 1 over 1. You will get the exact same answer. I just prefer to do it that way so that I can do the subtraction for the similar terms because you will need to move the terms afterward anyway. So that is our definite integral for the question D here.